Okay, now we're going to do example 2, describe how to transform the graph of f of x equals x squared to obtain the graph of this here. This one we're going to go through a little bit quicker because it's the same exact idea as what we just did. This is the f of x equals x squared graph right here in pink, and then we're just going to transform it. So to come up with the A, B, H, and K. So remember, A is first, so what's ever in front of F? There's nothing in front of F, so that's 1. 1 would make that not any different, right? Do this in blue like we did before, so that's 1. B is whatever's in front of the X part here. X minus 2, so 2 minus 2 would give us 0, so H is 2, and then K is positive 1. Okay, so the effect of the graph on the parent function. So the 1 means it will have no effect, basically. You're going to multiply all of your, the A's, deal with the Y's over here, right? So, let's see. So the effect on the graph of the parent function, you're multiplying all the Y's by 1, which has no effect. Okay, B, that means we're going to divide all the X's by 4. So that means it's going to get multiplied by 1. All the X is going to get multiplied by 1/4. Okay, it's going to shrink horizontally by a factor of 4. The 2 here is with the H, so that means the whole graph is going to move to the right 2. And then K is 1. That means the whole graph is going to move up 1. Okay, so here's all of our effects here. Create a mapping rule to transform points on F to G. Okay, so we're just going to use this little formula here, right? So we take our X value and we divide it by B, which in this case is 4, right? And then we add H, which is 4. Oh, no, sorry, H is 2. Okay, and then we take A, which is 1 times Y, which is just going to be Y. And then we're going to add the 1 here. And away we go. Okay, so we're going to apply our mapping rule here. So we got points here, 0, 0, 1, 1, and since remember this is squared, 2 squared is 4. So we got 2, 4. So plug stuff in, 0 divided by 4 plus 2, and we got 0 plus 1, which gives us 0 divided by 4 is 0, plus 2 is 2, 0 plus 1 is 1. So there's our new vertex is at 2 and 1. So that's where it's going to shift over and up to, right? Over 2 to the right, up 1. That makes sense. I'll plug in 1, so we got 1/4 plus 2 and 1 plus 1. So that's going to give us 2 1/4 and not plus, but 2 1/4 and 2. So 2 1/4 and 2 is about right there, roughly. And then we're going to take 2 divided by 4 plus 2, and then we're going to take 4 plus 1 because our Y is 4 here, and that gives us 2 1/2 and 5. So we go over to 2 1/2 and up to 5, so that's about right here. So it's going up pretty quick here. It's going, okay, and then it's just going to mirror image. Okay, I didn't do the best job of that there. Oops, let's put that one back on there. So it goes up. Let me stop it and make a good graph. Okay, so that's closer. We kind of get the idea, and I put the little line of symmetry in there. So the symmetric point on 2, 1, that's the vertex, so it's going to be the same right there. It's right on that line of symmetry, and this is only 1/4 over, so it's going to be 1/4 over that way. So instead of doing our 2 and adding 1/4, we're going to do 2 and minus 1/4. That's going to be 1 3/4 and 2. And then for this other one up here, right there, we should put that on there. That one there is going to be, we're going to do 2 minus 1/2 instead of 2 plus 1/2. So that's going to be 1 1/2 and 5. And then that's going to be our other points here to make our graph. Something kind of like that. Okay? Okay, one last example, and we're all done with this one here. Okay. Engineers working on a bridge project are considering 2 different designs. Here they are. One design as a single tower supporting the roadway. Look, absolute value, quadratic. Okay. Model for the outermost cable of the one tower design, this one here, is in the form, here's the formula basically, where x is the horizontal distance in feet from the left end of the roadway, and C1 is the cable's height in feet above the roadway. So that's there, okay. And then the model for the two tower design is this here, a times x minus h squared, hence the curve quadratic, plus k. X is the horizontal distance in feet from the left end of the roadway. C2 is the cable's height in feet above the roadway there. So that's cable 2, cable 1, C1, C2. Okay, find the equations that model each of the bridge cables. Let's start with this one up here. All right, we know that this here is the vertex, right? So if we're looking here, the vertex x minus h, that's how far over to the right we went, which is 125. So this is 125 for that h. Okay, and then it's up 100, right? So that's the k is going to be 100. Okay, next we can pick any other point that we know on this graph for sure, and then plug it in for our x. Well, let's see, our x and our y, right? I'm going to choose 0, 0 because that one's a little bit easier. So now we know that this is 0 and this x is 0. So really what we have now is we've got 0 equals a, which we don't know. That's what we're trying to figure out. A times 0 minus, we know the h is 125, and then plus 100, right? Now we're just going to solve this thing. So we subtract 100 from both sides. We get negative 100 equals, let's see, if we, 0 minus 125 is just absolute value of negative 125. So that's just 125 times a, right? So then divide both sides by 125. And that'll tell us what a is. A is going to be negative. That's going to end up being, if we divide both of those by, what, 20? No, not 20, but we divide those both out by 25. That's going to be negative 4/5. So now we know a is negative 4/5. Okay, so now we can figure out, now we know the formula of this whole thing because we knew all these other pieces. We were just trying to figure out what a was. So now we have one formula is, let's call it C1 of x equals negative 4/5 times the absolute value of x minus 125 plus 100. So there's one of our formulas. Now let's do same type of idea with this one here. Okay, so the h is how far to the right or left it's gone, and k is how far up and down it's gone. So let's take a look at that. So we know it's gone over 125 and up 20. So this is going to be 125, and that's going to be 20. And then we've got these two. We can plug in either point 250 and 70 or 0 and 70. I'm going to choose that one because that one seems like it'll be a little bit nicer. So we've got 70 is y equals, okay, and then we've got a, which we don't know, and then we've got x, which we do know is 0, minus 125 squared plus 20. And now we're going to go through and solve this one. So subtract 20 from both sides, and we get 50 equals a times negative 125 squared, right? If you take 125, negative 125 and square it. So we know if we square something, we're going to get rid of the negative, so I'm not going to bother to put that on there. So 125, and we square it, and we get 15,625. So we get 50 equals 16, I already forgot, 15,625. And then that's going to be, so that's already the squared, so it's 15,625a, right? So we divide both sides by 15,625, and we find out what a is. A is 50 divided by 15,625. So let's just do 50, and then we're going to divide by our answer, and that gives us 0.032. Let's see if we can turn that into a fraction. That'll probably be a little bit nicer. So to do that on our calculator, we simply push the little double arrow button right here, and that will turn your decimal into a fraction. So 2 over 625. 625 is what our A equals. So that means our formula for this bridge thing here is going to be C2x equals A, which is 2 out of 625, times x minus 125 squared plus 20. So here's our two formulas. Why is the value of C1 negative while the value of C2 is positive? So C1 is negative because our absolute value function normally goes like this, right? But it's been flipped upside down. That's why it's negative, right? And then our C2 is positive because our parabola is opening up. So that means it makes a little smiley face, therefore it's positive. Oops, not cross it out. That's why it's positive. Okay. Find and interpret and compare the average rates of the change of the functions C1, C2 on the interval between 0 and 125. Okay, absolute value 0 and 125. We got 0, 0, and 125, 100. There's those 2 points. And for the quadratic, we got 0, 70 and 125, 20. So 0, 70 and 125, 20. To find the slope, you simply subtract the two y's divided by the difference of the two x's and for both of those, and away we go. So let's just set those up. So for, let's do this absolute value and quadratic. Okay, so for the absolute value, we're going to do, I like to do this, 100 minus 0 over 125 minus 0. And then for our quadratic, we can do the same. Well, here, let's simplify it first. So that's 100 over 125, which is going to be what, 4/5. So there's the slope of this one. It goes up 4 over 5. Right? Quadratic, we'll do the same thing. 20 minus 70. 20 minus 70 over 125 minus 0. So 20 minus 70 is negative 50 over 125, which that's going to simplify down to negative 2 over 5 if we divide both of those by 25. Okay. Find, interpret, and compare the average rate. So one's positive, one's negative, right? Okay, so the graph is increasing at a constant rate on the absolute value, while the graph is decreasing, not quite at a constant rate because it's curved, but from here to here, it's going down 2 for every 5, what is it, 5 feet or meter? Feet along the roadway we go, on average. Okay? Okay. That's all we have for the 1.4 transformations of absolute value and quadratic functions video. If you have any further questions, please feel free to ask in class.